Hello everyone, I welcome you all in the C programming and data structures lecture. This is part 6 of application of stacks, infix to postfix. So without any further delay, let's get started. In this presentation, we will learn how to write a program to convert an infix expression to its equivalent postfix expression. Okay? It is very important to write a program for the same because we have already seen this, that how to convert an infix expression to its equivalent postfix form. But we have seen the algorithm and we just got the idea that how to convert an infix expression to its equivalent postfix form. But in this presentation, we will try to write a C program for the same. And now, without any further ado, let's get started. Here is the algorithm which we are already aware about. This algorithm is capable enough to convert an infix expression to its equivalent postfix form. But these are just plain English sentences. This is just an algorithm. We have to convert this algorithm to its equivalent C program. And that's what we will do in this presentation, right? First, we have to write a main function, right? And here you can see I have declared all these libraries stdio.h, stdlib.h, string.h. We'll use the functions of these libraries later in our code. We have hash define max 100. So whenever we use max in our code, it will get replaced by 100 at runtime. Here we have a stack array. And you can see this over here, I'm using max, which will get replaced by 100. So the stack array is capable of holding 100 characters. You can see the type of this stack is char. This stack must hold all the operators, right? Even the left parentheses and right parentheses as well. So this is nothing but an operator stack. That's why I have chosen this char type instead of int type, right? Although you can select int also, eventually you can store characters in the form of integers as well. That's not a problem. Later on, you can use them and manipulate them. You can choose int type also, but for this presentation and for this program, I have selected this char type. Then after this, we have these infix and postfix arrays, right? You can see this. These are required because we will use them in our code. We'll use infix array to store the expression entered by the user. And we will use postfix array to store the whole postfix expression after the conversion, right? So these two arrays are required and they are declared globally, so that every function can use them, right? Later on, we will have a lot of functions. Then those functions will use these arrays. Instead of passing them locally, I prefer to declare them globally. And then we have the top variable, which is an integer variable. This top variable will hold the index of the stack, right? This top variable indicates where is the topmost element in the stack, right? Currently, top is -1, which means stack is empty. Now we have this main function. And in this main function, we want to write something. Of course, the code has to be written. For this purpose, step 1 is ask the user to enter the prefix expression. This must be the step 1, right? We must ask the user to enter the prefix expression. This is the first step. For this purpose, I have put this line of code, printf, enter the infix expression. User will enter the infix expression and I will simply store that infix expression in this infix array. As simple as that. To this, I have to pass infix to this getS function. That is getString function. This function is declared within this string.h library. That's why I have included this library over here, right? So in the command prompt, you can see this message will get printed on the screen. Enter the infix expression. Later on, user will enter this expression. Let's say this is the expression 7 plus 5 into 3 and 5 into 3 is within parentheses. We also have white spaces. Later on, we'll write the code to handle these spaces as well. But right now, I'm assuming that there is no white space between 7 plus, then plus left parentheses and so on, right? So assume that this expression has no white spaces, okay? This is how our infix array looks like after receiving the input from the user. Here you can see we have all the characters within this infix array. And at the end, we also have \0. Obviously, getString function will automatically add this \0 at the end to indicate the end of the string, right? So in total, we have 8 characters in this infix array. 7 plus this left parentheses, 5 star 3 right parentheses and \0. Total 8 characters, right? Now, step 2 is to call the function to convert the given infix expression, the infix expression entered by the user, to its equivalent postfix expression. That's what we have to do. We have to call the function, some function, to convert the given infix expression to its equivalent postfix form. For this purpose, I am calling this function into post. This function is capable enough to convert an infix expression to its equivalent postfix form. This is just an abstraction. Of course, we have to define this function somewhere, right? Now let's try to define this function. And of course, this function is dependent on this algorithm. Actually, we have to convert this algorithm to its equivalent C program. That whole piece of code is nothing but into post function. So this algorithm will get converted to into post function. Fine. Here first we have to scan the symbols of the expression from left to right. This is the first requirement, and for each symbol we have to do the following. For this purpose, of course, we need a loop. Let's say we create a for loop which will run until all the symbols of the expression are red. You can choose a while loop as well, it's up to you, but better is to choose a for loop, right? This for loop will run until all the symbols of the expression are red. This is our requirement. Of course, we want to scan all the symbols of the expression. That's why we need a for loop, and we'll read all the symbols of the expression with the help of for loop. For this purpose, iterator is required. This is I variable, and inside this for loop you can see this, that I is initialized to 0. This is the initialization step, right? Now what about the next step? What condition we should check here? This must be a conditional checking step. Now what condition we should check? Here we want to read all the symbols of this infix expression, isn't that so? We can put this condition: if we reach \0, if we reach the end of the string, then we should stop. We can put this condition: we'll read all the characters until \0 is reached, which means the end of the character is reached. But you can also check this condition: if I is less than strlen of infix, this function will return the string length, okay? And this function is declared again in string.h header file. Here you can see that currently we have 8 characters in this array, but string length function will return 7 instead of 8. It will return the length of the string excluding this \0. It will not include \0, okay? That is why this strlen function will return 7 instead of 8. Now we can check this condition: is I less than string length of infix? If it is the case, we'll continue. Otherwise, we'll get outside of the loop. So here in this for loop, we'll check this condition: is I less than string length of infix? Okay. Now, we will store the symbol of the infix expression in a variable. It is also a very important requirement. We must store the symbol of the infix expression, right? For this, we just need this line of code: symbol equal to infix of I. We know that if I is 0, then this will get replaced by 0. And infix of 0 means the first character of infix array. We will store that character in symbol, and we will use this variable later in our code for the purpose of condition checking and the other things that we have to do, right? So here, of course, we need the symbol variable, and the type of the symbol variable is char, right? As you can see, our code is building slowly, right? Now, what is the next step according to the algorithm? You can see this, we have multiple if conditions, right? We have to check these conditions. If symbol is an operand, if symbol is a left parenthesis, if symbol is a right parenthesis, if symbol is an operator, we have to check all these conditions. We can either write if else, or we can either use a switch case, right? We'll check all the conditions by using switch cases. Multiple cases we have to take, right? For this, we need the switch. And of course, we have to pass symbol to the switch. Later on, we will check the conditions one by one. Now it's time to check the conditions one by one and perform all the operations one by one. First, if symbol is a left parenthesis, we'll start from this step. If symbol is a left parenthesis, push it onto the stack, right? That's what we have to do. If symbol is a left parenthesis, push it onto the stack. For this, we'll put this case, left parenthesis, push, symbol, simple. Here we have to push this symbol onto the stack, right? If we have encountered a left parenthesis, we'll push this symbol, that is this left parenthesis, onto the stack, and then we'll break out of this switch case, right? This break is required after every case. Please don't forget this break statement. Then the next step is to check if symbol is a right parenthesis. This means we have to write case right parenthesis, then pop all the operators from the stack up to the first left parenthesis. We know that we have to pop all the operators from the stack and print them on the screen, right? But instead of printing them on the screen, I'm going to change this a little. We will simply store the operators in the postfix array. Okay, instead of printing all the operators on the screen, we'll store the operators in the postfix array. Later on, we want to use our postfix array for the purpose of evaluation, right? This is very important that we must store all the operators in the postfix array instead of directly printing them. So here, we know the requirement is to pop all the operators from the stack up to the first left parenthesis and store the operators in the postfix array, right? Definitely we need a loop. And in this case, let's say we take a while loop and check if the popped symbol is not equal to the left parentheses, then store that symbol in the postfix array. If it is the case that the popped symbol is not equal to the left parentheses, then we'll store that symbol in the postfix array. Let's call the pop function in the while loop itself. We'll call this pop function, and definitely this pop function will return some value, that is the topmost element of the stack. We'll store that value inside this variable next. That's why I've declared this next variable over here. And then after this, we'll check this condition. Is next equal to left parentheses? If it is the case, we'll get outside of this while loop. Otherwise, we'll continue to pop all the elements from the stack. First, we'll pop the topmost element. We'll check this condition. If it is not a left parentheses, then definitely we'll move and we'll store the symbol, the popped symbol, that is next, inside postfix of j++. I've declared this j variable also, and I have initialized it to 0. Initially, the first symbol will get stored in the postfix 0, then postfix 1, and then postfix 2, and so on, right? This is a post increment operator, right? So first, this j++ will get replaced by 0, and then after evaluation, this j will get incremented by 1. Simple, right? So instead of writing j++ here, you can also put j over here, and then after this statement, you can write j++. They both mean the same, okay? This is more compact way of writing this. Okay. Now, the next step is to discard the left and right parentheses, and it is very clear that this while loop will also discard the left parentheses. Because if we have encountered a left parentheses, first that left parentheses will get popped out of the stack. Then we are checking this. Is the left parentheses equal to this symbol? And obviously they are equal. Therefore, we'll get outside of this while loop. So this while loop is also discarding the left parentheses, right? So I hope the whole idea of this program is clear to you. Up to now, we have these two cases, that is checking whether the symbol is a left parentheses or right parentheses. Now let's see a very simple example so that we would be able to cement the concepts related to what we have learned so far. Let's say this is the simple example. This is the expression entered by the user. Although this is a very simple expression, but this is okay for this presentation. We just have to take this left parentheses, these two operands, and this right parentheses. In this case, of course, infix array will hold all these symbols, right? And of course, a \0 at the end. So there are total 5 characters in this infix array. Now, first we have to declare these two variables. You can see them over here. I is declared, and of course j is initialized to 0 as well. Here we have two variables, symbol and next. You can see them over here, symbol and next variables. These are character variables. And we have a stack as well, right? An empty stack. After this, we'll put 0 in I. So we'll put 0 over here. After this, we'll check is I less than string length of infix. In this case, string length is 4. So this will get replaced by 4. We're checking this condition, is I less than 4? Yes, of course, in this case, you can see that I is less than 4. 0 is actually less than 4. Therefore, we can continue and enter inside this for loop. Here we'll put infix of I, that is infix of 0, inside this symbol variable. So we'll store this symbol in this symbol variable. We know that index of this block is 0, index of this block is 1, and so on. Infix of 0 is this character, right? We'll store this character inside this symbol variable. And now we can use this. Here we have switch symbol, and we can see this, that this is a left parentheses. So this case is satisfied, right? Left parentheses. We'll push this symbol onto the stack. Let's push this symbol onto the stack. After this, we'll simply break out of this switch case. Now we'll get it to this point, that is I++. We'll increment the I by 1, and then we'll again check this condition. Is I less than 4? Yes, I is less than 4. 1 is less than 4. So we'll get inside. Now here we will put infix of 1 inside symbol variable, right? Because I is 1. So this symbol will get stored inside symbol variable. Now again we have a switch case. We know this time we have an operand, but here we are just checking these two cases. Let's make a default case. And in default case, what we will do, we will store the operands simply inside the postfix array. We know that operands will get stored inside the postfix array, right? So we'll use this postfix array and we will store all these operands. Whenever we encounter an operand, we'll store that in the postfix array. This is the default case. Okay. So we are handling one more step of the algorithm. That is, if the symbol is an operand, then we'll simply put that symbol onto the postfix array. So this is the default case, right? And here we are putting symbol in postfix of j++. First, this will get replaced by 0, right? Which means postfix of 0. Then after this, you can see that this is how our postfix array looks like. This symbol will get stored inside this postfix array. Then after this, j will get incremented by 1. Fine. I hope the idea is clear. Then after this, we'll increment the value of I by 1. This becomes 2. And then we'll check this condition. Is I less than 4? Yes, you can see this I is less than 4. Again, we will get inside this while loop. We'll put infix of 2 inside symbol. What is infix of 2? Infix of 2 is this symbol. We'll store this character inside this symbol variable. Then we'll call switch symbol. And we know that this is an operand. So this default case will get evaluated, which means this character will get stored at this position. Why is that so? Because you can see that this is j++. This j++ initially will get replaced by 1 and later on will increment the j by 1, right? So after storing and after evaluating this whole line of code, this j will get incremented by 1. I hope this whole thing is clear. Now again, I will get incremented by 1. This becomes 3. Then we'll again check this condition. Is 3 less than 4? Yes, of course, 3 is less than 4. We'll get inside this for loop. This will get replaced by 3. So here we are actually putting infix of 3 inside symbol. What is infix of 3? This symbol. We will store this character inside this symbol variable. Now again, we have this case. Which case? This time we have a right parentheses. You can see this over here. We have a right parentheses, right? So this case will get evaluated. Now in this case, we have a while loop. And here first we have to call this pop function. This pop function will remove the element from the stack. Right? The topmost element. Here you can see the topmost element of the stack is a left parentheses. We'll remove this or we'll pop this element out of the stack. And definitely this will get replaced by a left parentheses. And here, obviously this next variable will hold this left parentheses, right? This is an assignment operator. So this left parentheses will get stored inside this next variable. Now we can check this condition. Is left parentheses equal to left parentheses? Yes. So we'll get outside of this while loop, right? So we'll land at this line of code, that is break. Okay. Now we'll again get to this point, that is I++. This time I will get incremented by 1. So this will get replaced by 4. Now we'll again check this condition. Is 4 less than 4? Definitely not, right? So we will get outside of this for loop. And this procedure is not difficult to understand. Here we are checking all these conditions. We are actually handling 3 different conditions. Left parentheses, right parentheses, and whether the symbol is an operand or not, right? And this is the final postfix expression so obtained. But what about this condition? If the symbol is an operator, what to do in that case? We'll see how to write the code for the same in the next presentation. Okay friends, this is it for now. Thank you for watching this presentation.